All right, well, I'll get started just because I have a little intro to kick things off and people will join before we dive into the presentation. So, good afternoon, everyone. Thank you for joining us for today's webinar on InSAR satellite monitoring and universal data hosting. My name is Julia Hoggins. I'm the Senior Marketing Specialist at GeoComp, and I'll be introducing today's speaker. I will also be moderating the questions at the end, and we'll just go over a couple housekeeping items so that you're able to receive your PDH certificate at the end of the presentation. So today's presentation will run for about 45 to 50 minutes, followed by a Q&A portion at the end. If you have questions during the presentation, please drop them in the Q&A section, and Ian will answer questions at that end portion of Q&A. The webinar has been accredited as a professional engineering continuing education course by New York State and will provide one PDH to attendees. So you must stay for the entire presentation to be eligible for that PDH credit. After the presentation, you'll receive an email with 5 multiple choice questions that you need to answer in order to receive your certificate. So after you complete the questions and send them back to me, then I will send you your certificate. And we will also be sending you the slide deck, and a recording of a presentation will be available on our YouTube channel. So I will be sending a link to that as well. So now to introduce our speaker. Today's presenter is Ian McCusker. Ian graduated from Rensselaer Polytechnic Institute, RPI, with a bachelor's degree in geology and has worked at GeoComp for the last 10 years. Ian is the lead instrumentation project manager in GeoComp's Massachusetts monitoring division. He is responsible for overseeing the design, procurement, installation, and maintenance of geotechnical instrumentation programs on numerous large civil projects throughout North America. Ian also has extensive experience with geotechnical and structural monitoring instruments and automated data logging systems, vibration and noise control, and remote sensing. So now that we have the introductions out of the way, I'd like to hand it over to our presenter, Ian.
Thank you very much, Julia, and welcome everybody. Appreciate you tuning in for the presentation today. So without further ado, I'll kick it off here. So our agenda, thank you for the introduction. We're going to be covering some InSAR satellite monitoring, some case studies, and wrapping up with cloud data hosting. So the intent of this is sort of an introduction to InSAR technology, and then some case studies to look at actual applications in the real world, and then how to aggregate that data into a cloud platform so you can have lots of different ways to access your information in one place. So as Julia said, my name is Ian McCusker. I'm the lead instrumentation project manager at GeoComp. I appreciate the introduction and look forward to talking to everybody today. So starting off, we're going to be talking about InSAR. So satellite remote sensing, of which InSAR is one type of technology, is extracting information remotely without any ground presence required. So there's different types of remote sensing sensors, usually grouped into passive and active technologies. Passive technologies include optical and thermal sensors, which are usually using the sun or infrared emitted by the ground to measure the Earth, whereas an active sensor will actually send a signal to the Earth and retrieve it. So as a satellite orbits the Earth, it's constantly monitoring what's underneath it. So the satellites that we use for InSAR are usually in what's called a polar orbit, where they are orbiting around the poles of the Earth as the Earth is rotating underneath them. This allows them to revisit certain locations at specific intervals that are dependent on the satellites. Often we'll talk about revisit times of 11 or 12 days, but different orbits and different satellite technologies will have different revisit times to parts of the Earth. So we group Earth observation, remote sensing into 3 broad categories. Optical imagery, this is what you'll see if you log into Google Earth. They're a very common purchaser of optical data, and that's often the most common way for people to interact with remote sensing data. So that's just optical images of the Earth's surface. So that obviously requires sunlight for you to be able to see what's going on, and no cloud cover, because you need to be able to see the ground. You can also look at elevation data. There's a couple different ways to collect this. That's something that we're always happy to help with. And then there's radar data, which is what we're going to be covering today with InSAR. So that's an active monitoring technology that actually uses an emitter on a satellite to send a signal down to the Earth and look at what's coming back to it. So with InSAR, what are we actually measuring? We're looking for phase shifts in the InSAR signal. So that satellite is sending out a signal to the Earth. In this case, on this example, it's a 5.6 centimeter wavelength signal. And as it bounces back, you're going to catch that signal at a certain phase. And if you compare one image to the next, you can see if that phase changes, you've moved down that 5.6 centimeter wavelength. That's an indication that the ground has changed. So over time, you can see an evolution in the ground deformation. So you link together multiple images or scenes to produce a time series of measurements. So when we talk about the accuracy of InSAR, we often refer to millimeter measurement precision and accuracy. That's over long-term readings. You can see a trend start to develop as you compare image to image to image. So this helps you isolate any atmospheric changes, any slight deviations in the orbit of the satellite, and you're going to get this really clean signal over time that's showing you the Earth changing. So what does InSAR data actually look like? So this is a quick time series where you can see colors starting to pop out on the map. In this case, the yellow and red colors are an indication that there's settlement occurring, and blue is an indication of heave. So our theory in this case is that this is a large port project underway, and there's likely groundwater injection occurring in the center of the port area to help mitigate settlement that might have been occurring due to ongoing work. So strengths of InSAR. One of the key strengths here is it's remote. You don't need a site presence. You can capture data from anywhere in the world from your office. You don't need to have boots on the ground. You don't need to have intimate knowledge of what's going on the site. You can capture this data remotely. Over time, you can get to this millimeter precision. You can cover a wide area. You can have data coming in for thousands of square miles, while also having a dense measurement network where you can have hundreds to tens of thousands of discrete measurement points in a square mile in urban areas where you have a high measurement compatibility. So this can provide a very complementary information source to ground-based data. Another key aspect of InSAR that has proven really powerful is the historical data archive. So these satellites are orbiting 24/7. They're collecting data all the time. And you can actually go back and look at historical data from before you even thought to look at what's going on your site. For example, if there's a failure on a site and you want to see when the precursor signs started to show up, you can look at your historical data and really track what was happening. Or as we'll discuss in one of our case studies, if you're starting work on a site and you want to understand what's been happening before you ever engaged on the project, you can actually look backwards in time and see what was happening. And data frequency here, this is another key aspect. You can get repeated imagery over time and watch what's happening on your site. It doesn't have to be a one-off InSAR study. You can actually get regular updates every time a satellite passes by. You can get an update what's happening on your site and understand over time as things are changing. So challenges, we're going to go through some of the specifics here, but InSAR the technology, it's not a one size fits all. You need to be aware of your site. You need to be aware of the specific limitations of the technology. Key limitations are if there's large scale ground surface changes, often mining sites, if there's large changes going on in the active work areas, we're not going to be able to look at InSAR data. Vegetation can interfere with the InSAR signal, but there are ways around that. Climate conditions, obviously snow cover is going to interfere with your ability to see what's going on the ground. And if there's really large magnitude movements, for example, a large earthquake, we're going to have a really significant change. Or if you have certain areas with sinkholes where you have a really discrete sinkhole that opens up and is an abrupt change, it's going to be hard to pick out with the InSAR data what's actually going on there because of that sudden and sharp change. And ground resolution is another aspect to consider because obviously you're imaging from a satellite. You're not going to be able to see what's going on in a few square inches on the ground. Different satellites can have different resolutions, and we'll cover that. So summing all these up into some of these considerations, frequency, 6-day images at best, although depending on the satellite you use, that varies. You can get down to 1 meter resolution if you're willing to use satellites that use that 1 meter resolution, although at the moment those are commercial satellites that do have a higher cost associated with them. For InSAR, cloud cover is not a consideration. If you're looking at optical images, obviously clouds can interfere with your ability to see the Earth. InSAR will go right through a cloud, doesn't matter if it's day or night. Again, time of day, InSAR is immune to that. Viewing geometry, now this is something that, depending on the site, it's best to consult with the experts on if your site is going to be a good fit. This is often an issue because of the way that the InSAR satellites look at the Earth. You need to make sure your site is actually going to be visible in the right way to that InSAR satellite, because as the satellite is looking at the ground, it's looking at movement purely back and forth to the satellite. Now you can use multiple lines of sight to separate horizontal and vertical movement. But if your site is, for example, in a valley and you've got movement in one direction and the satellite maybe isn't able to see that perfectly, that could be a consideration. Ground control, so InSAR movement, again, if you're just looking from a satellite and you want to be able to verify with ground survey, you're going to want to be able to tie those together, and we'll cover how some of the technology to do that. Processing times are key. That's something you want to discuss with an InSAR provider. And ground cover changes. So InSAR, again, if you have significant vegetation, it can interfere with the InSAR signal. And there are ways around it, but it's something you want to talk to your InSAR provider about before you start on a project. So when is InSAR the best solution? So we got three groupings here. We're going to start off with ideal situations for InSAR. Wide area screening, when you're looking at citywide, countywide, even countrywide or continent-wide screening. InSAR is a perfect application for that because the satellites are imaging tens of thousands of square miles, and you can get really broad views of what's going on the ground. You can also dial that into regional and local site context. So if you've got, for example, a tunnel in an urban environment, you can look at what's going on, not just immediately above your tunnel, but you can look at the wider neighborhood impacts and potentially understand what's going on outside an area that would be conventionally monitored on the ground. It's very helpful. InSAR is a very good technology in urban environments with hard infrastructure, and getting that repeated data frequency, InSAR is very helpful. So some of the sites where InSAR can be the right fit as long as the site is appropriate. Larger sites, bridges, landslides, and coastal defenses are all great candidates for InSAR, as long as the site has the right set of conditions, and that's something that we're happy to help with. So situations where InSAR is not a great fit. So very small sites, if you're looking at a single building and you want to understand what's happening with it, InSAR might not be the right fit without some considerations to look at. Thick vegetation can interfere with InSAR signals. Some InSAR satellites are able to see through a certain amount of vegetation, but if you're in a really dense jungle, for example, you're not going to be able to get consistent quality InSAR data, and it might not be the right situation without adding some ground technology like a corner reflector, which we're going to talk about. Sites with large surface changes, for example, if you're excavating, you're doing bulk excavation on a site, that's going to resurface the whole area, and we're not going to be able to compare images from one overflight to the next. But you might be able to see the surrounding areas, what's happening, and this is why InSAR, sometimes if you combine with ground-based monitoring, you can get the right application to work. And small cuttings and embankment failures, the slide here shows a very small landslide on a railroad track. Obviously, this could be a catastrophic situation for the railroad, but this is a very, very small change to be detected from a satellite. So this probably isn't going to be the right application for InSAR. And this is probably something you're better off looking at ground-based monitoring to watch for these very small landslides. So one technology I mentioned was corner reflectors. So this is a tool that can help bring a site that might be borderline into a really good candidate for InSAR. It can also be used to tie ground-based monitoring with remote sensing. So a corner reflector is a special piece of hardware that you place on the ground that is tuned for the satellite monitoring technology that you're using, and it's going to respond to that satellite radar signal much more strongly than the surroundings. So the little image here is a raw SAR image showing the strength of the signal in an area. And each one of those little circled areas is a corner reflector. You can see they show up very, very brightly. And that's giving us a really strong signal to lock onto with InSAR and help get really good data out in a site that maybe has ground conditions that are not ideal for InSAR. So here's a couple pictures of corner reflectors. Example here you see in a hayfield where obviously you're going to have vegetation changing significantly through the course of the seasons, but that corner reflector is going to provide a consistent, strong signal year-round and help give your InSAR data a higher quality review over time. So we're going to cover a couple case studies here. These are our projects that we found really interesting and I'm excited to share with you. So the first one here is the San Luis Dam. This is in Northern California. This is a large water dam that impounds a reservoir that has significantly changing water levels. So we were engaged on this site for a historical assessment. So this project kicked off and we were asked to look historically before the project started at what was going on the ground to help inform how to monitor the ongoing work on the dam and understand what to expect from movement in the dam structure. So I've got two images here showing the reservoir extent for the dam. So these two pink circles are indicating the two dams on the site. And this image was taken in March of 2019. And then if we go to October of 2021, you can see that black area shrank significantly. So that's the reservoir extent. So these are two examples of the reservoir at full capacity and the reservoir having been drawn down significantly. So you can imagine there's very large changes in the loading conditions on this dam, and we wanted to understand how that might be impacting the dam over time. So we started off by looking at the vertical displacements. And so when you look at InSAR, often the simplest InSAR data is just line of sight movement, where you're looking at between the satellite and your ground conditions, what's the change that's happening. But if you're able to engage two views from the satellite, two different lines of sight, you can actually separate horizontal and vertical movement, get a better idea of what's happening in 3 dimensions on the ground. So vertical movement on this dam, we saw a little over 1/4 inch of vertical displacement over 4 years. So that was interesting, but not particularly alarming or concerning for a project underway. 1/4 inch is, in the grand scheme of things, not significant movement. But horizontal displacement, on the other hand, we saw over 1.5 inches of horizontal displacement over those 4 years. So on a project where you're going to have significant work going on this structure, that was a really key piece of information to know. Number one, where that movement is happening, and number two, the magnitude of that movement, so we can appropriately plan for the alert levels that we would apply on this project while work is underway. So we perform this historical study and then use that to inform our recommendations for the ground-based monitoring, and that ground-based monitoring is actually underway currently as work continues on this dam. One thing I'd like to point out here, this is the westward movement along the inner edge of that dam crest. So you can see here, there's over time some significant changes between readings, but there's a clear trend present. So this is one consideration to keep in mind with InSAR data. Sometimes you'll get reading to reading will have a little bit of noise, and you really want to look at the trend over time and see if there's a significant change in the trend rather than really looking at individual readings and comparing 1 to 1 to 1. And you'll see it from first glance here as we're looking at data from 2019 here. We can see that the movement at first doesn't really appear to be showing a consistent trend. We have a little bit of movement, it kind of comes back, but then all of a sudden the movement really starts to accelerate here. So that's an indication that maybe this isn't long-term consistent movement. This might be more closely related to site conditions. And it's something that, again, if you're undertaking a project of this magnitude, you really want to watch this closely. So another case study, which is near and dear to my heart, is the Crenshaw LAX Transit Corridor. So this is in Los Angeles. This is a significant expansion of the LA Metro. That's one of a couple projects that we've worked on out there. And this project, most of this transit corridor is actually above grade, but the key area that we're looking at is the below grade tunnel segment, which involves about 1.6 miles of underground work at the northern end of this line. So construction began in 2014. The initial parts of the line opened in 2022, although the southern section is actually still under construction. They're currently connecting with the existing line at the southern end of the project. And Geocomp was involved on the ground with over 2,000 ground-based sensors, especially focused on the tunnel segment as they were tunneling underneath an active roadway and active utility lines. So this is we called UG4. This was the tunnel and underground segment at the northern end of the line. And on the left here, that's our ground-based survey network. And on the right, you can see the InSAR results for that same area. Some key areas to look at here, especially near the southern end here, you can see both the ground-based network and InSAR were picking up some movement. The red here indicates it's a little over a ½ inch of movement. So again, in the grand scheme of things, that's not a huge change. And I think it speaks to the accuracy of our InSAR and our ground surveyors that were able to detect changes of this magnitude. And you can see on the ground-based data, there's a couple areas where we see some yellow and red. It actually tracks quite well with the areas that we're seeing in the InSAR data as well. So we're going to focus in here on a couple of the spots of the ground-based and InSAR data where we saw some of the most movement. And you can really see the comparison of these two different data sets. So here we've got in blue a single survey nail, and in purple we have the InSAR for that area. So the survey nail, this is a classic ground survey. We had a California professional surveyor team on site, often every day, sometimes multiple times a day, with a survey staff. They had 2 or 3 teams running at a time during some of the most critical work phases. They're collecting a lot of ground-based data. And you can see over time the settlement that's occurring in this area. And then on top of that, we went ahead and plotted InSAR data. You can see they line up quite closely. So as another example, here's another area where we've got ground-based data and then the InSAR data coming in, plotting right over the top of it really closely. And our third example here, again, we have ground-based data showing really no change, and then all of a sudden you can see settlement starting to be picked up in both data sets. But one key thing to note here is right at the end of this data set, our InSAR data shows some continued settlement where our ground-based data doesn't. And at first glance here, one thing that jumps out at me is our ground-based data is actually on the edge of a building, whereas the InSAR data is looking at the roadway and the building here. And so unfortunately, we don't have any data for the roadway here, but the InSAR data is showing that there's some actually significant movement happening in that roadway. And that might be why we're seeing continued settlement in the InSAR data when we're not seeing it on the ground-based data, because we weren't measuring the asphalt change for the ground-based data. We're really only looking at the buildings that we were most concerned about. So our third case study here is a closed mine site. So we were engaged on this site to look at the movements of a tailing storage facility over time as they were demobilizing from the site. So up on the top part of the image here, you can see this is the TSF wall here. So this is the tailings dam, and they have a tailing storage facility as well as a bunch of other ongoing working areas and a processing facility. So this is a tropical area. They were planning on demobilizing from the site and letting it revegetate naturally. And most of the hard infrastructure on the site was planned to be removed. So right away, when we were talking about considerations for InSAR, vegetation can be an issue, and hard infrastructure often responds best to InSAR data. But unfortunately, in this case, we knew that we couldn't count on that hard infrastructure sticking around long term. So if we're going to be monitoring this long term, we need to have a better solution. So in that vein, these are what's called coherence maps. This looks at how good quality InSAR data you can expect to see from a site. So on the left here, we've got 12 days in February of 2019. You can see on our very scientific scale here from bad to great, it actually doesn't look too bad. We have some good coherence on the site, but then fast forwarding to May 2019, it really falls apart. You can see we still have some good coherence in some of the roadways and some of the buildings on the site, but most of the key areas that we're concerned about really don't have good coherence. And that's an indication to us. Often when we look at these sites, you have a gut instinct about what you can expect from coherence and what the best approach might be, and then looking at the actual hard data that really was confirmed here. So we deployed corner reflectors on this site. As discussed earlier, this is a great tool for sites where InSAR might have some challenges. Those corner reflectors can really bring that InSAR data and help it shine. So on the top right image here, we have the SAR intensity image before corner reflectors were deployed, and then again after these corner reflectors were deployed on the ground. So each one of these little white dots here is one of those reflectors really shining clearly in that InSAR data. So corner reflectors can have some challenges because now when you're talking about InSAR being remote sensing technology, you don't need boots on the ground. Now with corner reflectors, you do have a ground presence. This site, we actually started deployment of these during COVID, and we were unable to send any staff to the sites. We're relying purely on local site presence to install these, and we had some issues on this image here. If you have a corner reflector in a swamp and it's going to get flooded with water, that's not going to give you great return over time. On the one hand, it's sinking into the swamp, and on the other hand, you also have it full of water that's going to interfere with our satellite signal. So these, again, this is when having the right team involved can really be helpful. And despite these challenges, we had some really great results from this site. So you can see here, these are two of the locations on the site. This top chart shows the movement over time on the actual tailings dam. So this is the primary concern for the site. We obviously don't want to have any tailings dam failures. These have been in the news a lot lately. These are projects that Geocomp and CGG have worked on quite extensively. And in this site, it's clear that that tailings dam has been stable during the monitoring period. You can also see there is some significant settlement happening in the center of the tailings storage area. This is to be expected. The tailings pond has been decommissioned. They've stockpiled their waste and they're expecting it to settle over time, but it's contained and it's performing exactly as designed. And this was a great confirmation for our client that their site was stable and secure and that they had done their jobs well. So going over to data management here, this is us tying all of this together. So now we're talking about InSAR data, ground-based data. How can you take these different information sources? Often you have these really broad scale results, and how do you tie this together in a way that makes sense and is easily accessible? So this is an example here. This is the LA County area. This is an InSAR raster. So this is InSAR data collected over Los Angeles, as well as some example ground-based data. So with your InSAR data, you can see here we've zoomed in on the top section of the map where we have this really clear red section that there's something going on. It's an indication on this map. This is a heat map, so that red is an indication of larger displacements. So we've drawn a cross section through it, and you can see some significant displacements over time. This is actually the Beverly Hills Fault, and this is an indication of ongoing movement in the area. You can imagine if you're working on a project in this area and you want to monitor changes over time, you want to look at InSAR data and ground-based data. Having this information easily at hand is really key, so you can understand what's going on your site that's being caused by construction, that might be caused by natural movement of the earth, and really getting a better and clearer understanding of what's going on. So when we talk about a cloud-based web monitoring platform, this is really an ability to collect data from any sensor and deliver it to anywhere in the world. It can help you support real-time informed decision-making and get reports into your hands in a way that is going to make sense to any of the users involved on a project. And when we talk about it being cloud-based, this is a system that is on the cloud, so you're not relying on any one server and any one location to provide you this data. This is something that's going to be accessible at really reliable amounts of uptime, and it's going to be accessible quickly anywhere in the world. So a cloud-based data management system isn't just a website that you look at. This is really the full picture. So it starts with design and installation. So this is ground-based monitoring, this is InSAR, and actually deciding what's the best technology for a project, designing that system, and then implementing it and actually making it happen on the ground. So if you're working with a data provider, having that full picture can be absolutely key, because it's not just streaming data to a website. It's really starting at the design phase, managing that data, and then reporting it out at the end of the day to the stakeholders who care most about it. So here's a great graphic here that talks about all these different types of sensors and information, tying that all into one central system and then distributing that out to the people who need it. So web-based data management, what are some of the key features of a web-based cloud data management system that are really key to look for on a project or for long-term use? So there's a lot of different options out there. There can be different options that might be better fits for different applications. But on a broad scale, these are some of the key metrics that we advise everyone look out for on any of these data management platforms. I'm going to start with data integration. So this is the word I like to describe here most is data agnostic. So the best data management systems are going to be able to take readings from any system and combine them into one place. So I've worked on projects where we've got clients who are complaining about having 4 different websites to log into to access different types of information. And that can be a huge headache. That can be more than a headache. That can be a liability if something's starting to go wrong and you need to access information. Having everything in one place is so key to understand really what's going on and being able to make informed decisions. So you can have data from multiple different sources, different hardware manufacturers, different sensors, different formats of data. They're coming into a system in many different ways. A lot of the modern systems now are using APIs, which are application programming interface that allow you to connect in and get data directly from a source. But there's also FTP sites. There's different ways to host data on the cloud. And sometimes even there's systems that send out automated emails that you need to capture that and store it. And you can then store everything in one central location to access on the web. Another key feature of web-based data management is document management. So this isn't just about sensor data. It isn't about logging in and seeing if your site is experiencing any settlement. It's also having contextual information easily at hand in some of these critical situations. So accessing instrument installation documents and site reports, an emergency response plan. So if you get an alert, you think something's going on the site, having that response plan right there in the web-based system will help you make the decisions and respond to that appropriately and quickly and make sure you're doing everything you're supposed to be doing. Having these documents tied to different user permissions. So again, the people who need to see it can access that data and see what they need, but also you can control who can see what. So that if you have stakeholders maybe who don't need to have access to the full site, they don't have access to everything. 24/7 access. So this is one of the key elements of having a cloud-based system. It really gets you this uptime better than 99%, sometimes better than 99.99%. You don't have a server running in someone's garage where it's going to be turned off for the weekend. You don't have issues with downtime due to upgrades. Having a truly modern and advanced data management system, you're going to be able to have this really, you can count on it for this uptime at a really high cadence. And you can also count on being able to access it even if there's upgrades going on in the background. You really shouldn't need to take this website offline for any significant amounts of time. You should be able to access it anytime, anywhere. GIS enabled. So GIS stands for Geographic Information Systems. So these web-based data management platforms are at their core a GIS system, but having GIS data integrated with it is very, very key in understanding what's going on your site. So it's not just logging in and seeing sensor data. It's being able to integrate that with data from satellites. You can have site drawings. You can have different types of base maps where you've got streets and labels for buildings, but also you've got satellite imagery, topographic maps, which often can be government-issued topographic maps. You can have on-site imagery taken by drones. You can have digital elevation models. Having all that tied into one place, again, easily at hand, so you can access the information you need all in one place. If you have a sensor that's showing some movement and you are able to look at the elevation model of the site and look spatially where your sensor is on the site, how that compares to the elevations that have been documented previously, and you can start to intuitively understand what's going on and really get up to speed quicker than having different reports. You got to thumb back through, oh, this information is here, you know, this imagery was stored in a report, it got emailed over to me, I got to go try to dig it up. Having all this information, again, key information easily at hand to be able to respond and make decisions in an informed way. So intuitive interfaces. So this is something that can be maybe easy to overlook because you log into these systems. People who use these systems every day become expert users very quickly, but all of your users aren't going to be in and out of the system day in, day out. You're going to have people who maybe want to log in once a week, once a month, scroll through, make sure they understand what's going on. Or if you have something going wrong, you have a bunch of new users piling into the site, trying to understand what's happening immediately. Having an intuitive interface is so important to making sure everybody is getting the most out of the system. And that's something as simple as being able to click and drag around a site, use your scroll wheel to zoom right in. Again, most of us, right, I think all of us are very familiar with how Google Maps works, and having an interface that just makes intuitive sense to someone who's used to interacting with technology in the 21st century can be so key in, you know, not having to view a training video on how to access the information on the site. You log in, you see a map, there's colors on the map that are indicating something's going wrong. You can zoom in right there, click on it, you can see what's going on with your sensor. There's little icons, again, that make intuitive sense. You've got documents, you've got charts. You can hover over the icons to understand what they mean if you don't understand it right away. And you're able to navigate through this site without needing any extensive training. And then a uniform experience. So again, if you've got an interface that makes sense to you, having a uniform experience on that interface, no matter what device you're on, again, is so helpful because you might be looking at this on your laptop one day, and then the next day you get an email and you click on the link in the email and you're on your phone now. Being able to access the same information, it's plotted in the same way, you're able to move through the website in the same way. That really helps you understand what's going on, and you don't have to, you know, get back up to speed again in a different way on a different interface. It's all the same, the same ability to interact, uniform across all devices anywhere in the world. So customizable reporting. So this is, again, something that maybe is easy to overlook at first if you think you're just going to be logging in and clicking on some data and understanding what's happening. But almost every project I've worked on, you need to be submitting these reports, sometimes daily, sometimes weekly, and that's getting filed away somewhere for record down the line, or it's getting submitted in to someone who doesn't want to look at the website. And generating these reports can become a huge burden if you don't have a system that's friendly and compatible with them. So the system that we use here at GeoComp that's designed in-house is iSight Central. We actually have the ability to connect Microsoft Word and Microsoft Excel to the iSight database for your projects. You can actually go in, generate a report with charts, with data tables, summary information about alerts that are happening, and that's all in Microsoft Word. So then you can add a different header to it, you can add contextual information, you can have a report where you have a field staff member that puts in their field notes every day. They type them up, they put them in, and then they hit update, and every single chart for every single sensor on that project has been updated automatically, and you go ahead and submit it. And again, that's something that I've come across projects where I've got clients who are used to going through and looking on a web data management system, but they're actually screenshotting images of sensor charts and pasting them into the report. And as efficient as you might be able to get with going through screenshots, if you've got hundreds of sensors, if you've got thousands of sensors, being able to just click a button, update that report, Oh, you want to throw another chart in there? That's not a development request. You don't have to ask anybody to do it for you. It's right there in Microsoft Word. You can go ahead and update that right away. All these automated reports, then you save it, you send it out, and you're able to get that reporting done so much faster than any other potential options. So alerting and alarming. So this is a feature that I've touched on a little bit when you talk about getting an email on your phone maybe, or something's gone wrong on a site. But alerting and alarming in these systems is absolutely essential to responding to changing conditions on a project or on a site. So an alert can be as simple as getting an email if a sensor crosses a certain threshold. And in a basic form, if you have a settlement point on a site and it's moved more than 1/4 of an inch, you get an email about it and you respond to it. But there's a lot more to an alerting suite if you have a project that might need it. So setting high and low levels, setting different threshold levels. So we often use a traffic light system at a minimum. So green means the sensor is reading normally. Yellow means that you have an emerging problem on the site, and usually is an indication that you need to have a meeting and discuss potentially changing means and methods to prevent any further exceedances. And then red is often used as a stop work condition. But you can actually add more colors to that. Maybe you have a teal alert that is at 90% of your yellow alert level. Because often if you're setting off an alert, that might mean that there's bigger ramifications than just changing means and methods. Their stakeholders are getting notified. People are starting to ask questions about what might be going wrong. Maybe you want to have an internal alert set up so that you get notified before it even gets to that yellow mark. You want to have alerts if a sensor isn't behaving normally. So maybe a sensor hasn't showed settlement, but maybe it's showing nothing. You want to get an alert if there's a potential problem and you have an interruption in your data. You want to have the ability to generate alerts based on scripting and changes to sensors beyond just a single level. So you might be able to set up rate of change. Maybe you have a change point analysis going on where you're looking at sensor data and you want to see if there's a deviation outside the normal. You want to be able to get those alerts all in one place again, and then getting a timely notification. So that can be an email alert to your inbox, but you can also set up text messages. So you get a text message on your phone. Hey, there's a potential problem on the site. You open up your email. There's an email with the same information, but then in those, there's a link that you can click, and that'll bring you right into the website. You put your credentials in, and then as soon as you log in, because you clicked that link, you're brought right to that sensor. You're looking at what's going on. You've got all that contextual information right there. You can change your base maps. You can look at linked documents. You can look at linked sensors. So maybe you've got a sensor and an inclinometer that's showing movement. Right away, you can click and say, well, any one of these sensors doesn't have a lot of meaningful information for me. I want to look at what my inclinometer is doing across the entire length of it. You click right there into the chart for the whole sensor string, and you can see what's going on. You can look at historical information. And again, you can then look at your documents. You can see if there's certain levels along that inclinometer that pass through sensitive strata. That's all noted right there in the system. So you're not looking back through old reports. You're not trying to find information and understand what's going on. If it's been set up in the best way possible, all that information is right there for you to access without any second thought. And the last point I'll focus on here, because this is such a key consideration, especially in the last few years, is data security. So having access to your data is important, but making sure people who shouldn't have access to your data is probably just as important. So data security can be the entire database, making sure you're safe from hackers. And these cloud systems are not all created equally. There's definitely key ways that you can have data stored in the cloud that make it more secure. But then also for people who do have access to your system, maybe you want to control who can access what. So we often set projects up where you have different levels of access for different stakeholders. So as the example here on the screen, you've got unrestricted access for, these are administrators, these are people who are setting the entire system up. But then you've got multiple sites, you've got multiple stakeholders on these sites. They don't need access to everything. They might just need access to certain parts of it. So you've got a maintenance team who are looking at existing plant operations, and they're going to care about a certain set of sensors. and you don't maybe want to overwhelm them with information from everything else that's going on. So you just have them limited to the sensors that actually impact their day-to-day needs. You've got a construction site that is active in one part of your plant. You've got a construction team that has access to those sensors, but maybe they don't need to see what's going on everywhere else. And then maybe you've got an abutter, a building owner near your project or near your site. They might have requested access to see what's going on with their building. And if you've granted them access to that building, maybe you don't want them to access everything else that's going on. You're giving them the information that's relevant to them, but they don't have access to everything else that's in the system. They don't have access to the response plans that have been set up. They don't have access to maybe early precursor signs of movement. They really only have access to what actually impacts them and what's relevant to them. And then you've got, as an example here, TBM operators. So if you have a TBM that's a tunnel boring machine, if you have a TBM that's mining underground, those operators are going to want to see what's going on right away. So you can give them access to that data. You can also set up a web data management system to push data directly to the TBM operator's cab. So as they're mining underground, they have a live readout in front of them, and they can make decisions minute to minute about what's happening on the ground above them and how they're interacting with it. And I've seen this be very critical on certain projects where having timely access to information can make all the difference in the world. And again, hosting on a reliable platform is part of this data security. Having reliable access to your data is so important. You don't want to have downtime. You don't want to log in and it's Sunday afternoon and you find out that the system's been down for a couple days and you're not going to be able to get in touch with anybody until Monday. That's not acceptable. You need to be able to access your system 24/7 without any interruptions. And if there is, for some reason, a key need to have the system have a little bit of downtime, you want to be notified about it ahead of time and be able to coordinate that downtime to make sure it's not going to have any negative impacts on the end users. That wraps up my presentation here. I appreciate everybody's time and attention on this. I guess we'll pause there and see if anybody has any questions.
Yeah, we do have some questions that are coming in the Q&A section. Thank you, Ian, for that excellent presentation. All right, so let's tackle some of these. Okay, how much do corner reflectors cost? Any special installation requirements?
So corner reflectors can be quite low cost because there's no special technology here. At the end of the day, it's a couple of pieces of sheet metal that are oriented in just the right way. And so we're happy to work with people to get those manufactured. It's something that we can provide directly, or if we're working on a project, we can actually help you guys source them locally and work with a local machine shop to make them. So I think it can be surprising how low cost they can be.
Cool, thank you.
Yep.
Okay, so this one is a multi-question. So first part is, how much can iSite Central be customized?
So iSite Central is GeoComp's internal data management platform. So it's something that we've developed in-house. We have a team of software developers here. So at the end of the day, that means we have full control over customization. If there's a project that has a special need, that's something that we are happy to talk about and happy to add to our development timeline. Obviously, we have our own development timeline. We can't just add features at the drop of a hat, but we have full control over the system. So we can really customize it to suit a certain project need at will.
Perfect.
Yep.
Any limitations with point density? InSAR over large areas can have a very large number of points that can break many web browsers. So on that topic, how do you handle overplotting?
Yeah,
So
that's something that we've actually given a lot of thought to here. And this can be an issue with a lot of systems. It's something that we have spent a lot of time in. Basically, if you're zoomed out, you're looking at a wide area, you're not seeing the full point density resolution there. You're seeing a sort of summarized, zoomed out look. And then as you zoom in, you're seeing a higher and higher resolution rasters as you zoom in. So we do have the ability to kind of scale that, and that's something we're happy to work with people on projects to really deliver those results. So it's something that we can definitely give higher point densities than maybe people are used to seeing.
Great. How much can InSAR data be used in litigations? Can it be validated by professional surveyors?
Yeah, so one thing for litigation to keep in mind is InSAR can be used historically. So we've seen it used in litigation projects where nobody was monitoring at all. And then you come in after the fact and there's been a failure, there's a problem, and you can use historical InSAR data to validate what was going on the ground. And that can be really helpful in a forensic investigation, understanding what was happening, because maybe there was no survey going on. But if you're talking about using it forward-looking and can be validated by professional surveyors, our case study there showed that InSAR data can be really closely linked with ground survey data, and I think it's a really powerful technology. It's not an unknown technology. It's not something that is sort of on the fringes. It's very well understood. It's very well researched and documented, and it's very well understood for litigation purposes.
Great, thanks. Okay, another question. Can alerts and thresholds be defined using calculated fields or just static values?
Yeah, so you absolutely can do that. So you can have, for InSAR data, you can have point data, you can have a certain area of your data generate an alert if the average movement in that area is over a threshold. And then you can also be calculating metrics off of certain areas and certain readings. So on our system, we call those virtual sensors. So one example is I worked on a project where we were looking at movement of a structure, but we were also looking at the rate of change of movement of the structure. And so we had boundaries set up for if this bridge had racked over a certain amount, it would set off an alert. But they also wanted to know if it was starting to accelerate, they wanted an alert maybe before it even got to that global limit. So we had a rate of change limit set up on a couple key points, and we were watching those day-to-day change. And that structure actually was having a lot of thermal changes. So we documented what the normal rate of change was in the day-night cycle, and then watched that over time during construction to make sure that wasn't exceeded.
Great. All right, couple more questions. Are there InSAR technologies that deal with vegetation better?
Yeah, so I touched on this a little bit. There are. So there's a couple different InSAR providers out there. One of the common ones that we see frequently is the Sentinel-1 data, which is the European Space Agency's satellite. There are also some commercial operators, one of which is the SAOCOM satellite, and that's an L-band satellite, which does better with vegetation. But because it's commercial data, you do have to pay a little bit more for it. So often Sentinel-1 data is free for anyone to access, and then you just have to have the right team involved in interpreting the data, but it doesn't handle vegetation as well as some of the commercial operators out there. And we have arrangements with all the major commercial InSAR providers. We're happy to work with people to provide the best fit for their site.
Perfect. And then just one more question. So has using a data management system made a significant difference on any projects you've worked on?
Yes, so that was another thing I mentioned a little bit. Having timely information can be so key. I was working on one job. We had a tunnel boring machine mining 24 hours a day, 6 days a week. And we had extensometers above the tunnel crown looking at subsurface movement as the TBM was passing beneath them. And there was a team of us on call. I think it was 3 o'clock in the morning. I got a text message alert that we had a limit exceedance. And I woke up, logged into the system, and I could see one of our extensometer anchors was dropping pretty quickly. And by the time I called the site team to let them know that was happening, the TBM operator had already gotten the alert in the cab. They were investigating what was going on, and it turns out that some of the grout nozzles on the TBM were clogged, and so their pressure readings looked normal, but they weren't actually injecting grout into the annulus of the TBM as they should have been. So they cranked the pressure up, they equalized the system. We actually saw the anchor on that MPBX push back up, and it prevented them from exceeding the red limit on the site, which would have shut down the whole operation while it was investigated. And that TBM operations in particular, there's so many moving parts. They're fantastically expensive to operate. Having any unscheduled downtime can be a huge, huge negative impact on the project. So having that immediate alert helped respond before we got too much movement happening, and it helped the project continue without having to stop. So that was really cool to be involved in. It's really neat to be, I'm getting an alert and I'm calling them to let them know that there's an alert, but because the system is set up to let everybody know, all the key stakeholders had already been notified automatically, and there were already plans in place to address it before anybody even got on the phone.
Awesome. We have a couple minutes left and there's a few more questions, but we'll answer one more just to be cognizant of time. So this person asked, interested in an outline of costs. Are you able to have a trial example run and see and use it on a particular test or project site?
So yeah, cost really depends on the site, how much data we need to process and which provider is the best one. That's something I think best suited to a conversation to have offline. So I'm happy if you shoot me an email, I'm happy to look at it. Really, it's a pretty crazy scale, because if you're using Sentinel-1 data, and that's open access data, so we don't have to pay a satellite provider for the actual raw data. We're just processing it and delivering it to you. That's a pretty significant cost difference compared to paying for commercial data, which can be higher resolution or maybe better at a certain vegetation, but you have to pay the satellite providers, and you can imagine the cost to put a satellite in orbit are significant, so that data does come at a premium.
All right. Well, we're almost at time, so I just wanted to make one final note before we log off. So for anyone who missed the beginning introduction of the presentation, after we log off, I'll be sending out the 5 multiple choice questions for all attendees to answer in order to receive your PDH. I'll also send along the slide deck that Ian presented with today, and a recording of the presentation will go up on our YouTube, so you can reference it to help you with the questions. It may take a little longer just because sometimes the file takes a little while to load if it's a long 1-hour presentation. And then, as Ian just mentioned, if you have any additional questions that he didn't get to, or things that come up, or any sort of interest you might have in InSAR, feel free to shoot him an email, and I will include that as well in the email I send out with the PDH questions. And that's all. So thank you guys so much for joining us today. Thank you, Ian, for this great presentation, and we hope you all learned a lot and are interested in the topic.
Thank you very much. Everybody,
Thanks, everyone.